Hey, I'm recording. That means you should act like you're really studious, okay? Hello, friends. Alright, sit down. You, with the hair. Sit down. All right. You, with the lungs. Sit down.
I'm looking for my woman.
It's new material.
Oh, nice. I have a chance.
In fact, it's our last section of the year.
Oh, God bless America.
No. It's here. I'll pass out tissues in there.
Don't forget to assign us some summer packets. That just means nothing quicker than these. We'll go over the summer.
You don't have a summer packet for Sam.
Oh, you going to
Alright, so I have a little bit of a crazy warm-up for you here, okay? This is simple. It looks not bad, right? There's only a couple numbers. There's not much going on here. But it's a little bit of a challenge. I like doing this to you, don't I? I like throwing an equation at you that you don't yet know how to solve.
And never will.
Isn't that fun? So I just want you, that's why it says by inspection. I just want you to like kind of, noodle around. So you tell me what do you think? What do you think?
So
have a
would you
good
find it
guess.
fun if you saw a function you didn't know?
Yeah.
You would enjoy that.
Absolutely. Yeah, a new creature. It's like being a zoologist out in the wild. If you were like to discover a new species or something, wouldn't that be like the best day of your
If you
life?
discover a new species, you can name it.
You could name it after. You could name this new function that no one's ever seen after you. It could be like the M function or something. I don't want you to be talking unless you're talking about this. Okay, in which case that's cool. Please. Can you come up with a solution? How about this? If someone can give me an X value that works, I will give you a high five. Carlos has an answer. Wait, don't tell me yet. Let's give everyone a chance to think about it for a second. Do you have an answer already? You think you have an answer? So tell me. Oh, you know you do. It is true. Listen, guys, if you think you have an answer, then you can know whether it works or not because it works, right? Just try it. If it works, then you're right. It has to be. It has to work if it works. Right? So try stuff. Does the number 10 work? I don't know. Try it. It's number whatever. I have something else though for you. Those who think they're hot shots. Could there be maybe another?
Yeah.
There could probably be like 100.
Maybe there could be 100 answers. Could there be a third answer? I want you to think about it. Greg, did you come up with an answer yet? Any X value that works? What X values have you tried? Like, let me give you an example. For instance, does 4 work? All you have to do is check. 4 minus, what would 4 over 4 be? 1. So 4 minus 1 is 3, not 0. So 4 doesn't work, for example. So try another number. Why you gotta yell it out like that, Alan?
I don't think 2 works either.
Anything that makes
wait, 2
0
does work. Alan, you're a smart man.
Alan, is it, what? Did you get that from Carlos?
No, I did. But I had a feeling it was.
You have, yeah. Did you get that, Chantal? What was the answer that he said?
I'm not going to be here tomorrow.
Oh. You heard 2?
I'm still like autistic.
Does it work? Does 2 work? Does it? JC? Does it?
What?
Does it work, JC?
Who else is JC?
JC?
Oh, what?
JC.
Oh, JC.
I didn't ever realize that.
And of course,
Christian religion, behavior.
Little church and state there, sorry.
JK.
2 works? It works?
Yes.
Does it work for you, Mitzi? It's 2 minus 4 over 2.
Wait, -2 can work too, right?
Yes.
Alan, did you come on with that yourself?
No,
Alright. Hat is off. 2 and -2. 2. Did you check that? Does -2 work too?
No.
It does.
It does.
Yeah, -2
I got it.
minus -2 is 0. Yeah.
Wait, did I get it wrong? Oh.
Crazy, right? Isn't this exciting?
This is not like this.
So now, I mean, this is the big question. You should be at this point dying to know if there's like maybe a more systematic way of coming up with these solutions than just guessing and checking, right? So that's what we're going to try and approach today a little bit. But before I do, I have something very special to show you today. I would like to show you how to solve every equation that you ever meet in your entire life. Are you ready?
Okay.
Did you hear what I just said? This is going to change your life forever, JC. Okay? I'm about to show you how to solve every equation that you've ever met in your entire life.
Why didn't we teach going this beginning?
Well, that's a great question. We should just never have taught anything else except for we should just have done this. Okay, take your calculator out, and here's what I'm going to ask you to do. I'd like you to graph this equation in y1 on your calculator, right? The function, we're going to treat this, you might be thinking, why am I introducing another letter? But promise, this is going to be good for us. Y equals 4x minus 4 over x. All right? And I think we're going to be a little surprised about what it looks like. It's like kind of an interesting, got a little interesting look to it, maybe. So let's, I don't know, maybe we'll just do zoom standard. Let's see this guy. Whoa, whoa, whoa. You see what I see?
Hey, there's an asymptote.
There's something kind of crazy going on. Did you expect an asymptote on the graph?
No.
Yes.
Why should you, though, expect an asymptote, and where would it be? I know we've never messed with this function before.
Because it was over x.
But it's over x. If x happens to be 0, then this thing like has a hernia, right? I mean, that's a little bit too vivid. Sorry. Blows up, though. I mean, it's undefined. If x is 0, doesn't this thing... Right. So maybe, I mean, we don't know why everything else is happening. Does this look like it has a horizontal asymptote?
No, it has a vertical.
It actually doesn't have a horizontal asymptote. So this is an animal that we haven't really thought about very much yet. It's kind of exciting, actually, isn't it? You've never seen this before. It's a new species in the wild, Marcello. What do you want to call it? This is the Marcello function, everybody. Okay. No, you don't. You don't think it's exciting at all. I know. Okay.
I like the picture.
You like the picture? Good. Okay, good. Why are we doing this? Oh yeah, that's right. We want to solve this equation. If I solve this equation, what do we really mean? If I let y be this whole thing, what would I like y to be? I'd like to know what x value would make y 0, right? Wouldn't that be fun? So I'm looking for when y is 0 on this graph. Can you find places where y is 0 on this picture?
Yes, 2 and negative 2.
It looks like at 2, if x is 2, and if x is negative 2, we get a 0 on the graph, right? And remember, if you want, you could actually calculate those zeros using your 0 feature on the calculator. And if they were not nice values, like say it wasn't negative 2 and positive, say it was like negative 2.34 or something, you know, could you still find it on your calculator? Of course you could find use this second calculate 0 thing. Go to the left, like, I don't know, negative 3, go to the left of where we are, and then to the right, how about negative 1? You can also use your arrows. Press enter, it says take a guess, press enter. Blink, blink, blink. Negative 2, if you plug negative 2 in, do you get 0? Yes, you do, right? Negative 2, comma 0. And if you do the other one, trace to 2 there. You just hit trace and then hit 2, and then you'll see it's 2, 0. So we're good. All right, so you can kind of use the calculator to assess that we're right.
You hate it when I use the calculator. You always mark a point.
I know. I'm going to show you an algebraic technique today that you could confirm then in the end that it works with the calculator. Okay? All right. Are you okay?
Yeah.
All right, sorry. 9.6. Like I said earlier, a second ago, this is our last section of the year. And then we're going to start reviewing. We're going to have like a week of review before the exam. So we got some things to do, don't worry.
Well, we can make a last one.
We are going to have a unit test covering all of this stuff, all the rational function stuff.
Wait, on the unit test, it's still going to be the step from last, like, was it prior to the quiz, we just did? Okay.
Yep. All right, so if you want a title at the top of your notes, why don't you put this on the top of your notes? 9.6, solving rational equations, which should make sense. Because that's, in the warm-up, what I just had you do, isn't it?
Yes.
The warm-up was us solving a rational equation. But we just did it by guess and check. Like I said, you should, after seeing that, you should be like, wait, I know there's got to be a more systematic way. I'm a mathematician. I'm looking for I'm looking for patterns, for methods, for ways to methodically do that, not just guess and check. All right, are you ready? Today's notes just basically consists of just doing a couple problems, really. Let's see if we can get this. Solving rational equations. It says it on the board over there too, yeah. 9.6. All right, take a look at this one, for instance. Exactly right. If I ask you the same thing, solve. Ready, go. By inspection, it would be a little bit hard to just guess. By inspection, I just mean like, could you guess? Guess and check, right? I mean, right? This one's a little harder to just guess a value that works. I think you'd see, right? I'm not just saying that because I think that's true for any of us. Not whether you or me. I don't think it would be easy to just guess and check on this one. It's not easy either way, but I think you're going to like what we're about to do. So here is the one power play I'm going to show you today that will get you through every problem. Are you ready? Pay attention. If there's one thing you pay attention to right now, it's the following. Multiply this entire equation, both sides, every single term by the LCD. And what is the LCD here? And by the LCD, I mean the thing that would actually kill all the denominators. 2 would be a good thing to multiply everything by, right? Because that would kill this denominator, wouldn't it? It's also going to introduce some stuff going on over here. What else would you like to multiply by? So I think the LCD is 2. What else do we need? X. 2 and x, right? And by 2 and x, I mean 2 times x. All right, so I'm going to multiply everything in this equation by 2x. That's called the LCD. But it's also called the denominator annihilator, right? It's going to kill all of the fractions in this picture. And you're going to like that, because right now this is scary. In a minute, it's going to be awesome. You're going to really like it. I promise, okay? So just trust me that multiplying by the LCD, and by the LCD I mean the LCD of every single thing total in the equation. And remember that this is 2x over 1. I mean, I think we'll just probably say as we go forward 2x. But just remember that really we're multiplying each of these fractions by 2x over 1. So I don't know if we need to write this every single time, but let's do it here. So we have 2x over 1 times 4 over x. And I told you, we got to multiply this on both sides, every single term. 2x over 1 times 5 halves. And over here, 2x over 1 times negative 11 over x. Okay? Like I said, I don't need you to write this particular step every time. You can just write down the thing I'm about to write down. So for each one of these, like let's look at just this guy first. What does that come out to be? There's this first guy right here.
Huh?
What does this come out to be? 8x over x, or just 8, right? And then like I said, the reason we're even doing this is so that all the denominators go away. So if in the end you have still a fraction, then maybe you multiply by the wrong thing, or maybe you still haven't canceled out the things that need to be canceled out. But yeah, this just comes out to just 8. Do you agree? 8 over 1. But let's just write 8. This guy here. What about this?
It's not 8x.
Well, it's 8x over x, isn't it?
The X cancels out.
And the x cancels out, right? And the point I'm making is that you might be like, oh, that's kind of nice. Well, that was the whole point of what we did, is so that would happen. Of course it's nice. Yeah. What happens here in the middle with this guy? The 2 cancels out, leaving what is all that's left? 5x. And what about on the right side over here? What do we get? The x's cancel out, leaving, what do we have? Negative 22. And stare at this for a second. What did we just do? We just turned something that's really hard looking into something that like we could give to your little brother. Right? Look at it. Isn't that easy now? It's a nice little simple little linear equation. Subtract 8, divide by 5, call it a day, right?
Who wrote it like complicated ways in the first place?
Well, it probably models some interesting thing that we're thinking about in life, right? But it turns out to actually be pretty easy to solve. So what do we get? Do you get what I got? You get negative 6? Notice here that we only get one answer. Is that okay?
Yeah.
I mean, it's maybe a little bit, maybe you already have that question in your mind. When do we get one answer? On the warm-up, we got 2 answers. Why? Is there a time when we'll have no answers? Possibly. Is there a time when we would ever have 3 answers? Could that happen? Yeah, all these things are possible, and we want to kind of build some intuition. Do you want to check this on the calculator too? I think you're going to find checking answers is actually going to be a really, really good thing to do in this section. Okay, take a look. I'm gonna graph because I think maybe you don't know how to check it, right? I know you're feeling a little lazy, but I want to make sure you're not just lazy, but you just don't. I know I want you to check it, but I'm worried that you don't know how to check it.
Yeah.
Okay, so here we go. Ready? So I'm going to put in on one side. I'm going to put in 4 over x plus 5 over 2. That's y1. And then I'm going to put this in the other side. Negative 11 over x.
Ooh,
What do you think of that?
Ouch.
So if y1 is 4 over x plus 5 over 2, and y2 is negative 11 over 2, what would we like to have happen?
Wait, what?
We'd like to be able to put an x value in here, and, sorry, 11 over
What?
x.
Yeah.
what?
11 over x.
Just chase. I just grabbed it. It looks crazy.
It does look a little crazy, right? As I said, I don't know that actually this is... I want to put an x value into this equation, and an x value into this equation, the same x value, and get... I mean, what are we looking for? We're looking for this expression... We're looking for this expression up here to be the same as this expression, aren't we? Isn't that what this is saying here? We'd like to know when are these two things equal? That is, when are these two y coordinates the same? Is there ever an x value that you put into this function and into this function that yield the same answer? Does that ever happen? Is the question? Well, maybe, or maybe not. Let's see. If we, I'm actually going to do one more thing. Have you ever done this before?
My pastor mentioned it.
Oh, yeah.
Make that bold, maybe, just so we can see it a little better. And then I think I have Zoom 6 still. I think that's good.
What about Zoom 9?
Zoom 9 is not maybe as good on this one, I think.
Why is it thick?
Because he made it bold.
So I made y1, the left side of the equation, I made that in bold,
How do you
right?
do
So
that?
if you go in y equals to here, arrow over to here, you actually have a bunch of different options. Click on that and you can get a dashed line, keep clicking, and you get other stuff.
Cooking what?
On this little thing over here, go over
Oh,
to
I just
here.
made it bold.
Yeah, and hit enter a couple times and you get different stuff. You hit enter once, you get bold. Cool, right?
I never knew that.
So the bold one, ignore the other one for a second. The bold one is the left side of the equation. The one that's not bold, if you can ignore the bold one now, that's the right side of the equation. Isn't that cool?
What?
And I know we're getting caught up in the joy of this, okay? But let's not lose sight of why we came to this place in our journey. Listen, shh, okay? Is it clear that if we plug in like 3 into this equation and into this equation, we get 2 different values? Is that clear from this picture? If we plug in 3, we get some value, and if we plug in, here actually, let's do it. If we plug in 3, oh, that is overpowering. Sorry. Is that you, Jennifer?
What?
What's the beauty shop away? Man, oh my gosh.
Hello.
All right, if we plug in 3, take a look. If we're on y1, we get this value, but if we're on y2, we get a different value, right? If x is 3. Does that make sense? My question is there ever an x value that we plug in, that we choose, that gives us the exact same y value? Apparently this one isn't it, right? But is there ever an x value that gives us the same output on both graphs? Maybe it's not obvious. Let me zoom in just a little bit over on the side here. Oh, my throat's closing up.
Maybe we'll stop learning that.
That's not nice.
Oh, they should kick out the class.
The class
That's
makes me
what I
so
would do.
sad.
They could go,
Not you, the
it's
class,
school
like-
suspension.
It's winterman. You're obsessed with this little fish thing. Looks like a freaking fish.
You see what's happening? You see what's happening?
Look how nobody laughed at me.
Because I said everything.
No, you didn't.
All right, I can take a look what I have here. Is it a little clearer now? Is there ever an x value that you plug in and you get the same y value? Guys, can you stop? Sorry.
What?
All right. Is there ever an x value that you plug in that you get the same y value? What is it?
Would it be the cross or the?
How about -6? Do you get the same y value? It's the intersection between the two curves, right?
Yeah.
Is the solution we're looking for. How many times do these curves intersect? Well, apparently, only one time. On the warm-up, did that curve intersect the y-axis, the x-axis twice? Right?
So
Yeah.
would where it crosses the x-axis, what does that do? Like what number is that?
It's aloe vera.
That's also an interesting thing. That's when this equation equals 0.
Oh, okay.
Right, but that's not what we want. We want this equation to equal this, right? Does that make sense? Yeah.
So you
Jocelyn?
have to still guess, though?
No, you could actually find the intersection using a calculator. Second, calculate intersection. And if you didn't know what that intersection was, right, you don't know what that is, you just hit enter, 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 and then watch, boom, -6, comma 1.8333.
You can just go for this like too, right?
Yeah, I'd like you to be able to do the algebra, but take a look now on your table too, right? If x is -10, then these two expressions on the left side and on the right side yield these two numbers. Do you see that that's not right? Those aren't the same. If x is -9, you get two different values on either side. You can try all sorts of values. The only x value that ever gives you the same value on the left side of the equation and on the right side is -6. Do you see it? Pretty cool, huh?
Yes, indeed.
Anyway, all right. Let's move on. All right, I don't know if you need to write this down. I think it's pretty clear from what we just did. But what's our big power play today? We're going to multiply through by the LCD. And that's like it, right? That's going to apply to even the most complicated ones that we do as we move forward. Right, that's it. Hey guys, seriously, I'm going to come don't make
She's distracting me.
Staying away from my smells.
You
Delightful
have a
berry
zone,
house
it's true.
smell. It smells so good.
No.
It smells bad in here when you come here sometimes.
Oh,
I didn't say it was him.
Whoa,
Wait, that's my
you implied it.
No, I didn't.
I mean, it is his time.
Jennifer, just you guys simmer down, please. All right.
I know.
The power play that I just described is number 2. Do you see it? Multiply by the LCD. If necessary, number 1 might need to be done as well.
Oh, I hate factoring. We go over that because I'm bad at that.
And then this is more critical than you think, this last step down here. Check your answers.
What do you define extraneous?
We've actually given you this word before. Have you heard this word before? Extraneous?
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 I said extraneous.
Extraneous? Have you heard this word before? We've used it before in this course, I promise we have. It came up when we were doing radical equations, when we were doing log equations, and right? It's a solution that arises correctly from the algebra. You've done all your work right, but then it actually, when you go back and check it, doesn't work. Okay, and I want you to be really on high alert for that here, because that's going to happen in these equations too. You're going to do all your algebra right. You're going to get something that actually doesn't work. Okay, just be careful.
How is it possible then?
Well, that's a good question. Maybe we'll highlight that when we get there.
What are we gonna get there?
I don't know. We'll see. Can't ruin everything. We're like explorers in the jungle looking for new species. You know what I'm saying about those? Anybody else need this? I remember this is. I know, right? Can you throw it right? I know.
Good. You don't even sit there.
Hurry.
But I've been
Can I go out
quiet,
to
I'm
him?
taking
No.
notes.
There he is.
What?
It's almost due.
I didn't go in May.
All right, here we go.
I did it. You're right. I didn't go in there.
Yeah, you did.
But I said,
You went like on May 1st. Trust me, I have a wall. All right. Big task here is figure out what to multiply by, right? So remember, we want to multiply by the LCD, whatever that is, and it should be the thing. It should be synonymous with the thing that kills all the denominators. So what would make the denominators go away? You can multiply any side, both sides of the equation by anything you want. You don't have to do anything super fancy here. You just need to multiply by
LCD.
x minus 2,
Actually,
right?
it's already there.
Shouldn't you first rearrange it?
So we're going to multiply everything by x minus 2, or x minus 2 over 1, if you want. Okay, so what do we get? Over here, what do we get? What is 5x over x minus 2? Times x minus 2. Remember, we're multiplying this by everything.
Minus 10.
Whoa, hold up. What is,
5x squared. Minus, right?
don't overthink this. What is, here, we'll write it out actually. It's 5x times x minus 2 over x minus 2. Right? So what is that? It's just 5x, right? I mean, the whole point is that this x minus 2 kills the denominator, and what does it do to the numerator? Nothing. Right? Is that cool?
Wait, but, oh.
All right, what about the 7 times x minus 2?
Write this down.
Oh, I was thinking about.
And then what about 10 over x minus 2 times x minus 2? We're going to multiply this by everything.
Isn't it just 10?
It'll just be 10, right?
And you can graph this to check, right?
7x
Find the
minus.
intersection.
All right, well, actually, you guys finish this algebra here. For the same reason, I didn't write it here, but here, we'll write it. Let's do it. It's 10 times x minus 2 over x minus 2, and the x minus 2's cancel out. Okay. All right, so finish this off. Ready, go. The rest is, huh? Oh, don't share it. Don't tell it. See if you can work this all the way out. Actually, wrote it down.
Oh, I got it.
Yeah.
Hold on. Damn, I just tried to do it.
Actually, work it out.
Delightful bubbles smell. It smells so good.
I'm gonna sit down for a second. Huh? I'm not actually fine.
Actually, have you ever had the aloe drink? That stuff is good. It's like a little jelly.
How's this problem going for you?
Jelly.
You know what I'm talking about? Jelly. Big little
They
jelly
don't want a
thing.
window right there.
He legit doesn't like that.
Wow.
You can tell you never to do that again in class.
Like he's gonna bear.
I had Starbucks today.
What does that mean?
I mean, it dries out your skin.
You can put it on.
Jennifer and Jonathan and Marcelo, have you solved this problem?
I have a question.
Alright,
Let's go over this.
the next one was,
Because you never come over.
do I minus 10 first?
What do we get? 5x equals
You didn't even answer my
7x.
question, you just looked at me.
I know, I feel like you should know how to do this.
I don't, because I suck at math. Oh, I should probably distribute the 7.
I mean, this is 5x equals 7x minus 4. Do you agree with that, people? And
So you
then,
distribute the
mhm.
7.
Yeah. And then subtract 7x maybe? All right, and then divide by -2.
It's just like simple math after that.
Yeah, well, you could have solved it.
I just couldn't get.
Do you agree? Is that what you got, Mitzi? Yeah? Is that what you got, Natalia? Alan, is that what you got? Carlos, is that what you got? Justin, you with us? Okay. Too bad it's not right. Why? What else do we have to do?
Graph it.
You could graph it, plug it back in, and what do you see immediately without actually having to do any bookkeeping or work or anything? What do you see right away when you plug 2 back in? Is it obvious to you? What happens?
Wow.
If you plug 2 back into the original
it's
equation,
7 equals
wait, hold up. If you plug 2 into this equation, you don't have to go very far. What do you get down here in the denominator if you plug 2 in?
0.
You get 0. In fact, you have a problem over here, and you have a problem over here. X equals 2, if you graph these, and you're welcome to, I won't do it, but feel free to graph the two of these equations. What is happening at X
So
equals
this has
2?
no solution.
The answer is no solutions here yet.
I was the first to say it.
What is happening? If there's not, I mean, we thought earlier, if X equals 2 is the solution, maybe they cross there? No. What is happening there? What feature of both graphs, in fact, is occurring when X is 2?
Extraneous solution.
Well, it's an extraneous solution, but what in this context do you think it is? What's happening there at X equals 2 on both graphs? What'd you say?
They're probably the same.
Look at the graph. What is happening when X is 2? What happened in the equation? It blew up, right? What do you know happens on the graph?
I know what happened. I was the one who said no solution.
Did you graph it? What's
Me,
happening?
like, I'm just sitting here
Stop,
laughing
stop,
about
stop.
it.
What's happening there on both graphs? What is it? At X equals 2. If you plug in X equals 2, what's going on at X equals 2 on both the graph of the left side and the right side? What's happening? By blows up, what do we mean? What is it?
X equals nothing. Y equals nothing.
Wait, what's supposed to happen with that?
I don't know what happens at X equals 2. I'm wondering, why aren't we getting the two graphs crossing there?
There's a
Because
third
there's no
and a
solution,
fourth
and the
one.
bottom equals 0. It's X equals 2.
Wait, why are that one
We
the
already
same
discussed
place?
this.
I can't believe this is funny. It sounds so funny.
What happens when X is 2?
The bottom equals 0. And it blows up.
Well, it's not a line. What is that? I know it looks like a line, but what is that? It's an asymptote, right? On both graphs, you get a vertical asymptote at X equals 2.
Oh, that's
right?
where it blows up.
That's where it blows up, right? So it should make sense that on both of these graphs, what is happening? If they're not intersecting at X equals 2, which is what we thought maybe was happening, what is happening? They both have a vertical asymptote at X equals 2 is what's happening. Feel free to graph it and you'll see. Both of these have a crazy thing happening at X equals 2, okay? So bottom line is no solutions. These graphs never intersect.
Is it possible that they have asymptote and solution?
Sure, could be at different places, right? Which would mean it could be that we're gonna have, like later, we're gonna have maybe 3 solutions, right? Maybe we can have 3 solutions and one of them doesn't work, right? Does that make sense? So we could have any combinations. Here we got one solution, but we didn't actually work. So do these curves ever intersect? No. Okay, let's try another one. Again, be looking for how we can do our little power play. What do we want to do on both sides? How are we going to do it?
Find the LCD.
We want to multiply everything in the whole equation by some really choice thing. Yeah, maybe we want to think maybe both of those the denominators. But before we ever even get started, we might want to re-express that second denominator as
Factor.
in its factored form. Yeah. So what is that second denominator in its factored form?
X plus 1, X minus 1.
Okay, good. X plus 1, X minus 1, right? All right, so that tells me maybe a little more clearly what I need to multiply by. What am I going to do what am I going to multiply by that kills everything all at once?
X minus 1.
We need an X minus 1, and we need an X plus 1, and I think that will do it. Will that kill this denominator? Yeah, because one of the X plus 1s will go away. Will this kill this entire denominator? Yes. Will that introduce a whole mess load of stuff over here on the 3? Yeah, and that's just the way it is, I guess, okay? All right, so here we go. Let's do this nice and carefully. Here we go. So in the first one, we get 4x plus 1 times x minus 1 times x plus 1 over x plus 1. Remember, we're multiplying every single thing. This introduces an x minus 1 and an x plus 1 into every single numerator, right? So here we have a 12 times x plus 1 times x minus 1.
So even?
And the 3 gets an x. This is easy to forget. Everything gets an x minus 1 and an x plus 1. If you're multiplying both sides of an equation by 25, can you do that? Absolutely. Provided that you multiply every single thing on both sides by 25, you can do that, right? So that looks a little terrible, but now we get to do the fun part here.
Oh wait, stop.
I mean, this is the point, right? The whole point of doing what we just did is to cancel out all the denominators. So in a second, we should have no fractions left at all in our equation. Yeah. All I did is introduce an x minus 1 and an x plus 1 into all the numerators, right?
And now you can cancel out stuff, right?
Yeah, and then now the whole point of doing that is so that the x plus 1s cancel out here. What cancels out here?
X minus 1.
The x minus 1s and the x plus 1s. And then on the last piece there, nothing cancels out.
Wait. Can
All right.
the x minus 1 cancel out the x minus 1 again? Or no?
No,
Why?
because there's not a numerator and denominator, right? It has to be a numerator and a denominator. They divide out. By cancel out, we mean divide out, right?
Oh, yeah.
Right. So over here, do you agree that we just have 4x plus 1 times x minus 1 over 1? Okay, just
Yes,
that.
yes.
And then what's left here? Just
12 plus 3.
just 12.
X minus 1.
And then over here we have 3 times x minus 1 times x plus 1. Okay.
Yeah,
So we have some stuff that canceled out, and actually this is still actually pretty terrible, but notice there are no fractions. And even though this looks a little terrible, we have some work to do. Seriously, you and me, we're gonna have some work to do now. We're not done by any means. But what we're looking at is actually just a quadratic equation. Okay, so we're gonna be able to use this solve
How could you
this.
tell it was a quadratic
Well,
equation?
maybe you're not convinced. I'll show you in a minute that it is, I promise. Yeah, we're gonna have to multiply it all out, collect like terms, and I promise that we'll be able to solve all of the rest of what we have here using first semester technology, okay? But let's pause and make sure everyone's okay getting here. Is that okay? Stare at this for a minute and make sure, are you okay with what we multiplied by, with the factoring, with all the stuff that cancels out?
And that's it?
No, we're not done. I mean, we have work to do. I just want to make sure you're good here, because that was the new stuff.
You got excited.
That was the new stuff.
Wow.
Okay, here we go. We're going to do what Jocelyn and I were just talking about. Here we go. FOIL this out. What do we get? 4x squared. First, outside, inside. Let's see. Negative 4x and 1x is negative 3x minus 1 on the left side. Is that okay?
Negative 4x.
Wait, how are you supposed to FOIL out?
Negative 1
No,
and 4x.
spoiling this.
So 4x squared, you
But
agree?
not writing the middle terms that you have
Yes,
to
I
combine.
And then negative 4x is what happens when you multiply these. And a positive 1x. What is it, right? That's I combine those on the fly. Are you comfortable with that? Sorry. Over here we have 12 plus 3 times, what's this? What's x minus 1 times x plus 1? Guys, I can't have this together.
I don't even know what's going on.
Or we're gonna split all this.
Susie, this is my seat.
So, well, I'm gonna have to.
It's all because I still didn't even.
I didn't say
You guys,
anything.
stop. Don't make, stop. It hurts. Okay. What is x minus 1 times x plus 1? We've already covered that. Yeah, it's x squared minus 1. Beautiful. So what do we have here? We have, am I right that this is quadratic? 4x squared minus 3x minus 1 equals 12 plus 3x squared minus 3. Okay. I'm running out of room a little bit here.
Just trying to answer that at the space.
Yeah, we'll go up here. Okay.
That's exactly what
To the black.
I know it would be nice to work up the black. All right, so, but now I'm going to combine this over here. We have 4x squared minus 3x minus 1 equals 3x squared plus 9. You are okay with that? I'm just adding the 12 and the negative 3.
Because that's like terms.
Because like terms. And now what I want to combine like terms now across the whole equation. So maybe I subtract 3x squared on both sides. That'll get rid of the 3x squared over here, but that'll produce 4x squared minus 3x squared is just 1x squared. And if I subtract the 9 on both sides also, I think we're here. Do you agree? I want to make sure we can simplify this here using, again, this is just first semester stuff, but I know it might still be a little.
Why did you get to 0?
dicey because I subtracted both on this side. I subtracted both 3x squared and I subtracted 9, leaving over on this side nothing.
No, what did you subtract?
I subtracted 3x squared on both sides and I subtracted 9 on both sides. And when you subtract 3x squared on this side, on the left side, we just left with this here, right? Combining like terms. And if you subtract a 9 on both sides, that gets rid of the 9 over here and leaves. Yeah, you should do this.
Okay.
Uh-huh. You should get everything over to one side and have a 0 on the other. Because how are we going to solve this now? How do you solve? Now it's pretty clear that this is a quadratic equation. Before it was a little messy.
Okay, I stood up.
But now we've got it here.
Where did the 3x squared go?
I subtracted 3x squared on both sides. And when you do, on this side, it goes away. Do you agree?
Yeah.
If you subtract 3x squared on the right side.
Yeah.
Okay, and on the left side, what happens when you subtract the 3x squared? Can it combine with any of these things? Yeah, actually, the first thing.
Oh,
And that's where the x squared now comes
okay,
from.
yeah, yeah.
Does that make sense? Yeah, Jocelyn?
So the answers, you have two different answers?
Yeah, we have a quadratic. How do you solve a quadratic? We have like a whole mess of different ways to solve a quadratic, don't we? But I think the best way, remember I've said it's the threefold reason here. It's the fastest, it's the easiest, and it's the least error-prone way to just factor it. So I'm going to guess since this is a trinomial that maybe it came from two binomials. So how does that factor?
Oh, it has to add to -3 and multiply.
Yeah, we're going to guess this is an x and an x. Jesse's got it. He's already thought of it. Good. Wonderful. So, yeah, so either x plus 2 equals 0, which means that x must be -2, or it must be the case that x minus 5 is 0, meaning that x is 5. So I think that those are the two solutions. Go back and verify that neither of those solutions makes our original problem undefined or any issues with that, right? Are these actual genuine intersections between the equations on the left and the right? Feel free to graph the two equations and see that the intersections between those equations are the things I just said. Check for extraneous solutions though. I have one more I'd like you to do before you leave, if you don't mind.
No, it's not right.
I actually kind of get this, Mr. Chase. Jerry, Mr. Chase? I get this. So far, so good.
I'll be really impressed if someone can get this before the bell rings. All right, but I know the time is going away here. Yeah.
What do you do if not both solutions work out?
Then no solution. Yeah, then no solution. Then only one, that one solution. Exactly. Yeah.
In fact,
What do you? Yeah. How do you factor that denominator?
the only thing I have trouble with is factoring.
Yeah. How do you factor? That's critical here. How do you factor this denominator on the left? No. What do you always look for first when you're factoring?
A common thing.
Can you? Is there any common thing that can be divided out?
X.
Yeah. So we divide out an x. What do you have left?
Wait, oh, what is it? It's
Yeah.
yay.
All right. So what are we multiplying by? We want to multiply by x.
Wait, where did the 1 come from on the opposite side?
We're always multiplying by the LCD, which in this case is x and x minus 1. Yeah, it's the thing that is going to cancel everything out, right? So what does that give you?
You said we can do that in any equation?
The graphing thing.
No, like this thing where.
Well, all the ones we're doing tonight, all these rational equations, yeah, clear the
But you're still
denominator.
taking it.
Just multiply by the
Yeah, but that's
LCD.
the main problem I have. I don't know how to find the denominator. Least common denominator. I don't know.
What do you get? Anyone get this?
I know how to do everything after that, but I just don't know how to find. I don't know how to factor or find the least common denominator. Those are like two multiple parts.
Those are important, right? So you should stop. I mean, getting to the place where you can factor really well is like a little bit of a task, right? But you can practice, but I think you underestimated maybe the algebra 1 in the first semester. How important factoring is, right? Maybe back when you were learning, you're like, well, I'll just get this done. But you realize that like forever and ever for the rest of your academic career, we're gonna make you factor. It's like no, I did. When we taught factoring, I said this is the only way we have to solve it. No. I guess. I should have. It's all my fault.
No
All
one
right.
else should have to pay attention.